Standard 7.1 meets asks you to determine the horizontal x component and the vertical y component of a vector. An example of what this could look like is if a plane is traveling at a speed of 200 meters per second northeast at an angle of 49 degrees, what are the x and y components of the plane's motion? So the very first thing that we need to do here is we need to draw our line. This line that I've just drawn is my 200 meters per second at an angle of 49 degrees. In order to determine that angle or draw that angle in, I first need to draw my x and my y component. We always draw x first. Once we've drawn x, we can draw y. So I'll label both of these. Now, that angle that we've created in there is our 49 degrees. The next step is to solve for what the x and what the y component are. In order to do that, we need to use SOHCAHTOA. So to use SOHCAHTOA, the first thing I'm going to do is write down what I know. When I'm solving for sine, I know that the sine of my angle, in this case theta we'll say, is equal to opposite. Opposite of my angle is y over my hypotenuse. Now in order to get y all by itself, I multiply each side by the hypotenuse. I end up with your hypotenuse times the sine of your angle equals y. We can do the same thing over on the cosine side. So cosine of my angle is equal to adjacent. Well, adjacent to my angle is x over hypotenuse. Multiply each side by the hypotenuse, and I get hypotenuse times cosine of my angle equals x. If I solve for y first, hypotenuse is what I've drawn here as 200 meters per second. 200 meters per second times the sine of my angle, which is 49 degrees, is equal to y. When I plug that into my calculator, for y, I get a value of 150.94 meters per second. Now let's solve for x. My hypotenuse is still 200 meters per second times the cosine of my angle, which is 49 degrees, equals x. If I plug that into my calculator, for x I get a value of 131.21 meters per second. So another word that you could see in here is instead of determine the x and the y components, you could be determining the magnitude of the x and y components. Magnitude is just a word for value, right? So you're still going to do the exact same thing. Magnitude is just putting another word into the problem for you. At this point, we've now solved for my y and my x. So this is what the value of that y is, and this is the value of that x. Now we want to make sure that we've included our units on there, and we got our units from the original portion of the problem that we knew, 200 meters per second. That means we need to keep meters per second all the way through as we solve for both x and both y. The last thing that we need to do is double check the signs on both x and y. If x is going to the right, it should be positive. If y is going up, it should be positive. If x went left or y went down, we would need those to be negative numbers. So just keep an eye on your numbers and whether their signs are correct.